Okay, today we are discussing a power function, binomial power function. Okay, in this case, the hypothesis is composite. Look at the hypothesis. What is the hypothesis? H naught theta less than or equal to 1 by 2 against H1 theta greater than 1 by 2. So that is the null and alternative hypothesis. These are composite hypothesis. Okay. Theta equal to, if theta equal to a particular number, then that will be simple. Since this is some region, theta less than or equal to 1 by 2, that is a region. So it is known as composite hypothesis. So we are testing the composite hypothesis. The underlying random variable is binomial phi comma theta. So we know that binomial phi comma theta. What is the probability mass function of phi comma theta? What is the probability mass function of phi comma theta? Okay, I will. What is probability of x equal to small x equal to, what is phi probability phi comma theta? Yeah, phi c theta theta raised to x into 1 minus theta raised to 5 minus x, theta raised to x. X can be any number in between 0 and 0, 1, 2, 3, 5, 2, 3, 4, 5. Okay. Can you see this? Is it visible?
Yes, sir.
Okay. So this is the probability mass function corresponding to binomial distribution phi theta. Okay. So our aim is to find out the probability of type 1 or probability of type 2 and power. The null hypothesis H naught theta less than or equal to 1 by 2 versus H1 theta greater than 1 by 2. So we consider the rejection region. What is the rejection region? First we test the consider the test that reject H naught if and only if all successes are observed. That means out of 5 trials we are getting 5 heads. Okay, then we reject the null hypothesis. Look at this alternative hypothesis. This is theta greater than 1 by 2. That means theta may be 3 by 4, or theta can be 1, or theta can be 5 by 6. So that are the possible values of alternative hypothesis. So to accept the alternative hypothesis, we should have a maximum number of success. So that we are considering as the rejection criteria. So if we reject the null hypothesis if and only if all successes are observed. Okay, all successes are observed. So what will be the this is x. There are possibilities. X is a number of success. 0, 1, 2, 3, 4, 5. So this is a possible evidence that the proportion is greater than 1 by 2. Okay, what will be the proportion? If you obtain 5 success, then proportion will be 5 by 5. Okay, that is 1. That is considerably greater than 1 by 2. Okay, so we can consider this is the point in the or value in the critical region. So we will reject if we observe out of 5 trials. That is a considerable what is that? Rejecting this hypothesis. What is null hypothesis? Null hypothesis is nothing but theta or the proportion or the parameter. Theta is less than 1. If you observe these values, we can claim that the proportion is less than 1 by 2 in this example. Okay, so we consider 5 as the points in the rejection region. So what will be the power function or power function? What is power function? Power function is exactly, you know, the power function. There is a yeah, this is the power function. Okay, or let us define the power function. So what is power function? Beta function. Yeah, beta of x. Okay, under alternative hypothesis. Okay, so let us put so under null hypothesis, what will be this one? This is expectation of what is that? Phi of x. Phi of x under theta. What would be the phi of x here? It will be 1 if we observe 5. It will be 0 if you observe 0, 1, 2, 3, 4. That means this is exactly probability of rejecting H naught when H naught is true. Okay, when H naught is true. So what is this? What is this? Keeping x equal to small phi, then we will get the probability of rejection, because rejection region contains only one point, that is phi. Okay, when theta naught is true, what is theta naught? Yeah, theta naught is a number less than 1 by 2, where so we can write theta less than or equal to 1 by 2. Okay, so this is the probability of type 1 error. Okay, probability of type 1 error. What is the answer of this? We can remove these things. We need not to consider this. Okay, phi c phi is 1. No need to write this. Theta raised to 5 is theta raised to 5. Just write this only. So this is the probability of type 1 error. Okay, Now we compute the power. What is power? This is probability of type 1 error. Okay. Now what is power? What is power? Power will be taken under alternative hypothesis. So rejecting H0 when H1 is true. So what will be the answer? What will be the answer? Get reversed. Okay, because we are considering H1 is true, so theta greater than theta. We can simplify this. Power equal to beta 1 of x. Power is exactly equal to 1 minus probability of type 2 error. So that is exactly equal to beta 1 of x. So as in the previous case, we can use 5 instead of x. Okay. So what will be the result? Attain the result easily. Yeah, this is, we can remove this. Here we can put 5. We can put 5. Here we can put 5. Okay. Then in this case, if it is 5, okay, so in this case we can remove this term because that is 1, this 1, so just keep theta ratio 5. Okay, so this is the power equal to okay, power equal to probability of type 2 error beta 1 of x that equal to expectation of. So this is the power. What is the criteria? We have to restrict this one to a small number. At the same time, you have to maximize this one with respect to this region. Maximize power and minimize type 1 error. By maximizing power, we are simultaneously minimizing probability of type 2 error. Okay. So yeah, it is given here. This is nothing but theta raised to 5. This is the power function. Okay. Now let us look at the values. For theta less than 1 by 2. For theta less than 1 by 2, theta raised to 5 will be less than, okay, for theta less than 1 by 2, now let us consider this case. For theta less than 1 by 2, what will be theta raised to 5? Theta raised to 5 will be less than or equal to 1 by 2. Less than or equal to this ratio 5. Is it right? But this value is, that is given in this book, 0.0312. 0132. Okay, 3 1 3 3 1 2. Sorry, 3 1 2. So this is the probability of type 1 error. This is exactly less than some 0.05, right? So this is very small. This type probability of type 1 error is significantly small. At the same time, what is the situation of power? Hmm? Yeah, let us take this one. Or we can uh, what will be the power? Yeah, if theta greater than 1 by 2, what happens? Theta raised to 5 greater than min. Theta raised to 5 greater than 1 by 2 raised to theta. That means sorry, theta now theta greater than 1 by 2. So let us look at this. Sorry, theta raised to 5. Yeah, okay. Let us remove. This is not required. This is so our aim is to find out. Our aim is to minimize the probability of type 2 error or maximize 1 minus power. So what is probability of type 2 error from this equation? Can you say type 2 error? What is probability of type 2 error? Yeah, it will be 1 minus theta raised to 5. One minus theta raised to 5. Okay. This should be minimum. This probability of type 2 error should be minimum. For that, we consider this is less than 1 by 2 only when will it become less than 1 by 2? What will be the condition? We can move this part to the right side. So 1 minus 1 by 2 is greater than theta raised to 5. Okay, theta raised to 5. That means, what is this value? 1 minus 1 by 2 is 1 by 2. So we can replace with replace this with 1 by 2. Okay, 1 by 2 less than theta raised to 5. That means theta should be greater than 1 by 2 raised to 1 by 5. Theta will be yeah, that is 1 by 5. So if theta is greater than 1 by 2 raised to 1 by 5, this will be probability of type 2 error will be less than 1 by 2. Consequently, power will be greater than 1 by 2. Okay. So in this case, we can write what is that? Power. In this case, power is greater than 1 by 2. Equivalently, probability of type 2 error less than 1 by 2. So when power becomes greater than 1 by 2, when theta greater than 1 by 2 raised to 1 by 5. So that value is given here, theta greater than 1 by 2 raised to 1, that is 0.87. So power will be greater than 1 by 2 if theta is greater than theta is greater than 1 by 2 raised to 1 by 5. Okay, that value is given in this book. It is 0.87. 0.87. So if theta is greater than 0.87, power will be greater than 1 by 2. And moreover, the probability of type 1 error is less than 0.0312. So probability of type 1 error is minimum, probability of type 2 error is less than 1 by 2. At the same time power is greater than 1 by 2. So we obtain the, what is that, probability of type 1 error, type 2 error and power and its nature. Okay. Now we consider another situation. In this situation we are considering only the rejection region with x equal to 5. Okay. Now we move to the another rejection region. That is, the condition is we reject the null hypothesis H naught if x equal to 3 or 4 or 5. So if x equal to 3, 4 or 5, this is another situation. Do not mix with the earlier situation. This is a very different situation. That is, we are rejecting the null hypothesis if x equal to 3, 4 or 5. So what will be the power function? The power function will be like this: beta 2 of theta, that is probability of rejecting H naught. That means equally probability of x equal to 3, 4 or 5 under the alternative hypothesis. Okay. So that expression is given here: 5c3 theta raised to 3 1 minus theta raised to 5 minus 3, that is 2, plus 5c4 theta raised to 4 1 minus theta raised to 1 into 5cy theta raised to 5 into 1 minus theta raised to 0. So similarly, in a similar using the similar step as in the previous case, you can find out probability of type 1 error, probability of type 2 error, and the behavior of type 1 error and type 2 error when theta less than or equal to 1 by 2 and theta greater than 1 by 2, etc. So you can do that problem, do this problem as we seen here. Okay, similar argument holds. Just to replace the this term only, power function term only. Okay, instead of 5c5 we will use 5c3 and 5c4 term and 5c5 term. So and add this or add all these terms and you will use that expression as the power function. So you may do that. Okay, so you have to do similar analysis as in this previous discussion, similar analysis, and submit in the Moodle platform today itself. Okay, you have to simplify this one. What is 5c3? 5c3 is 5 factorial by 3 factorial. 5c4 is 5 factorial by 4 factorial. So you will get a simplified formula. Okay, using that formula you can find the computations, you can find the error probabilities and power. Okay. Next problem will be discussed tomorrow. This is the shape of the power function. Look at this figure. This is beta 1 of theta. That is a theta raised to 5. Theta raised to 5 will be a parabola like this. Beta 2 is, you will be simplified and you can plot that beta 2. The shape of the beta 2 will be like this. Okay.